So we are officially starting calculus right now, okay? So all the other stuff was kind of like, we're going to be using it a lot, but it's not considered calculus, okay? That was just considered factoring, or all the other things we did were going to be your second, third, or fourth part of the problems, okay? Now, a huge part of doing calculus and derivatives, especially at the very basic level, is all about finding slope.
Excuse the interruption, one more announcement.
Okay, so the easiest thing to find a slope of is a line. Okay, and that's in fact probably the only type of slope you've ever found. Now, the way you find slope is by your delta x over your delta y, or y2 minus y1 over x2 minus x1, or in words, it was always rise over run. Okay? And that's what slope is, and then b was always your y-intercept. Okay? So delta y over delta x is your rate of change. It's how quickly y changes relative to x. If delta x is positive, or delta y is positive, then it is increasing. If delta y is negative, it is decreasing. Okay, now you guys have done this stuff to death, right? I mean, you know that positive slope, you're going up, negative slope, you're going down. Okay, this one here would be a positive slope. So the delta y, so the change in y would be 5. The change in x would be 2. Therefore, 5 over 2 is your slope. So what that means is when x increases 2 units, y increases 5 units. So the less that x increases and the more that y increases, the greater the slope. Okay, if x is really small and y is really big, that is a huge slope. Okay, if x is large, so over a long time you increased very little height, that's a very small slope. Okay? And again, if you think about this stuff, you've been doing it forever, so it's not like you should be too on the edge of your seat right now. Okay, the greater the slope, the greater the range of change of y respect to x. So it's the faster y changes. So a low rate of change would be something like this. See, x is very large, and y is quite small. So y decreased very little compared to x. When you have a high rate of change, do you see that x is quite small, but y is very large? That would be a high rate of change. Okay, so this stuff you did in grade 10 a lot. How would you find the equation of a linear function that passes through a 2, 1 and b negative 4, 9? Now, if your main equation is y minus y1 equals mx minus x1. Now, this comes from the slope formula, because if you just took this and brought it down here, you could see that that's slope formula, right? Now, sometimes you've seen y2 minus y1. In this formula, when you're just finding slope, it is y2 minus y1. But when it's in the slope point form, it just uses x, and you'll see why when we do this question here. Now, to find this equation, I first need to know the slope, because I need to know m. So I want to find the equation of this line. Now, you want to keep this stuff straight when you're finding slope. Slope is y2 minus y1 over x2 minus x1. Okay, so maybe you want to go through, and I'm going to call this x1 y1 and this x2 y2. The reason I want to do that is so I don't mix these up. So to find the slope, I would go -9 minus 1 over -4 minus 2. That would give you -10 over -6, which equals 5/3. So now that I know the slope, I can put it into my slope point form. So we're going to put this in here. So I'm going to use 1 point to find my line. All you ever need is 1 point and a slope, and you could find the equation of any line. Okay? So I might as well use point A. So that's going to be y minus 1 equals 5/3 x minus 2. Okay, so I use the slope, 5/3, and point 2, 1. See, if you know 1 point and you use your slope, you'll find the other point, you can draw your line. Okay, but this will give you the equation of the line, meaning that any x that I put in, it'll give me any point on that line. Now we're not quite done, because we want to answer in general form. General form is when you have this equaling 0 and you have no fractions. Okay, so how do we do that? Well, first we're going to multiply this in. Y minus 1 equals 5/3 x minus 10 over 3. And at this point, let's multiply everybody by 3. So then I'll get 3y minus 3 equals 5x minus 10. Okay, so we got rid of all of our fractions. Now we must have this thing equaling 0. So it doesn't matter what side you want to put it on, but why don't I put it on this side? So that would be 5x minus 3y, because -3y is coming to the other side, and then I'm going to add 3 to both sides, so that will give me -7. Okay, this is general form. Okay, apologize for the speed, but we do not have much time today. Okay, for a linear function, 32x plus 4y minus 9 equals 0. If x decreases by 2, how much does y change? Now this is even worded in a way that many students just get kind of lost. All this is saying is, find me the slope, and then if x decreases by 2, what would y be changing by? If you know slope, you just do equivalent fractions. Well, the first thing we want to do is find out, well, what's the slope of this line? Because then if I know if x changes this much, I can find out how much y is going to change. Okay? So the slope is by doing the entire opposite of what we just did above. Okay? We got to the slope, or to the general form. We're going to take the general form, go back to slope. So the first thing we want to do is I'm going to get y by itself. So 4y equals -32 plus 19. 32x, yep, sorry. Okay, now divide by 4 to everybody, and y will equal negative 8x plus 19 over 4. Okay, now if that's the equation of the line, I know that the y-intercept is 19 over 4, and my slope is negative 8. Now, a slope of negative 8 gets kind of confusing because it's like, well, rise over run. Like, what's the run? I know the rise. Well, actually, it's a fall. But even though we usually hate fractions, slope is always nice to have in a fraction because it gives me two pieces of information when I write it into a fraction. So my m equals negative 8 over 1. So if x decreases by 2, I would put that there, correct? Because the x's go together. So now all I have to do is find the equivalent number that would work up here. Now, you can always do this by going negative 2 times negative 8 divided by 1, or just this you have to multiply by negative 2. We're going to multiply this by negative 2. Oops. So yes, the answer is 16. So y increases by 16. We know it increases because it's positive. Okay, so that's just a little bit of a review because I really need you to understand slope quite well because we are going to be talking about slope for a long time. Now, we're going to be talking about the tangents, okay? Now, tangents are lines and they have slopes, okay? Because what I'm going to try to figure out now is slopes of curves. Finding a slope of a curve is something you've never done before. You've always found slopes of straight lines. But that is the nice thing about calculus, is it can find the slope anywhere on a line, or sorry, on a curve. And we're going to learn, first of all, by using limits, and then later I'll teach you using derivatives. So what is a tangent? Okay, now tangent, it says for circles, but it works for anything. A tangent is a straight line that touches a circle only once. So if I wanted to find the slope at this point right there, okay, I want to draw a tangent to it. Now, believe it or not, there's actually only one tangent to that point. Okay, you could you could twist it this way or this way. Actually, no. I mean, if you magnified that small enough, you'll only get one tangent to a point. So the slope of that circle at that point would be the slope of that tangent. Okay? Now, easier said than done trying to find out the slope of that, but we're going to find it today. Now, for general curves, this definition maybe is inadequate, right? Because people could say, hey, look, that touches it only once. Okay? But what we're looking for a tangent, I don't know why these are in here. I don't want these right now. Okay? What we're looking for when we talk about a tangent is something that just touches once, okay? So do you see that these don't have a nice continuous slope all the time? If you look at the diagram here, do you see how the slopes are different throughout this entire graph? What's the slope right here? 0. Yeah. Okay, because there's the tangent you would draw would be right there. Okay? Now, you can also see how the slope of this entire part is positive, going to 0. Then the slope goes negative, right? Going to 0, and then they'll have a positive slope, okay? So at any point along here, so you wanted to find this point, you might be finding the tangent at that point, okay? So the tangent should just be touching at that point, okay? Now, some might argue, but look, it's going through the curve twice. I'm not looking at this point here, okay? So we just want to, because I mean, obviously I could stop here and I can find the slope of that line. I don't need it to go on for infinity, right? So as we do these, you're going to see that we want the tangent just to be touching, not going through, but just touching the line, okay? Now, I'm going to show you how limits, because we're going to be doing limits for this whole unit. It's the name of the title. How limits help us actually find the slope at a point. Now, if I wanted to find point, I wanted to find the slope at point P. Okay, now this is point 2, comma 4. Now how do you find the slope at that point? The slope point formula, what do you always need for the slope point? If you're going to find a slope, what do you always need? You need 2 points. Okay, well 0, 0 is right there. So if I was to draw a line, oops, missed it. If I was to draw a line, that's not really the slope at point P, is it? But you're onto something, because if this was, say, point Q, what happens if I start moving point Q closer? What starts to happen? Now, let's just pretend that this is the slope right there. I start getting closer to that tangent, don't I? Now, the line that's going through both spots, does anyone know what it's called when you actually go twice through? It's a secant, okay? So these are secants, okay? So down here, point PQ is a secant line. So what you want to do is get your secant. See, a secant, we can find the slope of a secant very easily. I have 2 points. Put in the slope formula. You're done. The idea here, so let's just write down, in calculus, we attempt to bring Q right to P. It actually becomes the tangent T. So the secant line, right down here, if you read this, it can be thought of as an approximation of the tangent line. So the goal will always to get looking like the tangent line. Okay? Now, we're going to keep working with this example. Now, just to be really clear, this is y equals x squared. That is the graph that we're doing. And we want the slope at point 2, comma 4. Okay? So, now as we move Q closer to P, the slope of the secant becomes closer to the tangent. Does that make sense to everybody? Okay? So, just going back here, if I put Q right here, say, do you see how that slope now is going to start to look really close to the tangent line? The farther Q gets away, it's more of an approximation. If you can get it, if you could get, what do you want the distance between P and Q to be? 0. In fact, if you could get it to 0, you would have the exact slope. Okay? So that's, you know, when people say you're pushing me to my limits, okay? That's what we're saying. We're getting as close as you always want to push your parents close, but you don't want them to snap, right? Because that's always bad. But it's fun getting there, right? So the whole trick is you want to get them close before they snap, okay? Because that's where, and then we'll learn a faster way to do that later. Not the parent thing. Okay, so let's find this slope, the m of PQ. So this is how we do it, m with a little p and a q. Now just remember the slope formula is y2 minus y1 over x2 minus x1. Now here's kind of a weird thing for you to see too. Let's just draw the graph here quick so I don't have to keep going back and forth every time. But if this is P here, and this is 2, comma 4, and this is Q, does anybody know what point Q is? Well, we do it in a general sense. This would be x, right? Does anybody know what the y value would be? Very good, x squared. So this is point x comma x squared, because it's y equals x squared is the graph. So what does y equal? X squared. Okay, so how do you find the slope between these two? We'll use the slope formula. So here's my slope formula. So y2 minus y1. So y2 is x squared, and y1 will be 4. x2, that's x, minus x1. Now, that's wrong. Now, what do we want x to become so these points are right beside each other? 2, which is going to make the bottom equal 0. So it's called a limit because you're not allowed to put 2 there. But we want x to be 2, because if you made x, so it's like if x was 1.9999999, I could go find slope, couldn't I? And I'm going to get really close, because if you look at this diagram right here, 1.999 is right there, and that P and Q are so close, that's got to be pretty well the slope at P. Okay?
The the interruption. The following students need to go to room 108 at lunch. Annie Bellenew, Ezekiel.
That can't be us. 12:10, right? Okay. So what we want to do now, one thing we can do here, which makes, so we want to find, this is like saying when the limit as x goes to 2 of x squared minus 4 over x minus 2. Now you just can't put 2 in there because that's going to be undefined. But that's the limit as x approaches 2. Now, you can also do a little math here.
Interruption, please ignore the bell that just rang. That is not for lunch. Thanks.
Okay, so I factored the top because we know that's the difference of squares, x plus 2 times x minus 2 all over x minus 2. Now what can I do? I can cancel. Now can I put in my limit? So the limit would equal, so now it's just going to be the limit of x goes to 2 of x plus 2. So I want to just talk about left and right. Now when we're talking about approaching 2, when you approach 2 from the left and 2 from the right, so we're going to approach 2 from the left. Now we're doing x plus 2. So if x was 1.999, now because of time, we could have started at 1.9 and then 1.99 and then 1.99. But I'm just going to show you, actually, let's do so if we started at 1.9 and you put that in there, you get 3.9. If you put 1.99, you get 3.99. If you put 1.999, you get 3.999. Do you see this is approaching 4? So what is this saying? As x approaches 2 from the left, the slope approaches 4. So as x approaches 2 from the left, the slope approaches 4. Now if we do it from the right, okay, from the right would be like 2.1, so that would give you 4.1, and then 2.01, that give you 4.01. Okay, if you put 2.001 in, that's 4.001. Okay, and again, you can see this is approaching 4 as well. So as x approaches 2 from the right, the slope approaches 4. Okay, so now we can find the slope of a curve. Okay, now to find the equation of that tangent line, okay, we know point 2 comma 4. We know that the m of the tangent line is 4, the slope is 4. So if we put that into y minus y1 equals m times x minus x1. Okay, so that would be y minus 4 equals 4 times x minus 2. Y minus 4 equals 4x minus 8. So we're going to get 4x minus y minus 4 equals 0. Okay, again, I know we're hurrying, but... Okay, so I'd like to do one more with you. Actually, we got 15 minutes, so... Okay. X squared minus 5x. So, what is x squared minus 5x? What's it going to look like? Okay, so if we just to get a visual here, okay, now, what would the zeros be? Because I could take out an x, that would be x minus 5. So my zeros would be 0 and 5. Okay, and if we completed the square, we'd get the vertex, but it's not huge right now. Now it says find the slope at point 2, negative 6. Okay, Jordan, every time I look over there, you're talking. That's got to stop. Okay, so I need to find the slope at that point. Now, basically, you can kind of look at it, and it would be maybe that. Okay, that's probably the slope of that secant. The only problem is, when I have it like that, I don't have 2 points to go find that slope. So if you could find another point, say Q here, this was P, right? Well, there's that. And do you see how if I keep moving Q closer, it will become right on top of... Okay, now, let's just do it like we did it before. Let's use our slope formula. M equals... So we're going to find M of PQ. Now, we know, let's call this X1 and Y1. What is point Q? X comma x squared minus 5x. Okay, so you're seeing the pattern now. X is always going to be there, and then the equation will go into y, because y equals x squared minus 5x. Look, it says right there, y equals, so why can't I put that as y2? Okay? So that's going to be x2, y2. So slope is y2 minus y1 over x2 minus x1. That would be x squared minus 5x. y1 is minus negative 6. That's plus 6. All over x minus 2. And we want to find the limit. We want our x here to get closer and closer to 2, don't we? So really, we're doing the limit as x approaches 2 of x squared minus 5x plus 6 over x minus 2. Now, really, I'm not supposed to show you the canceling and then bang, you could just put in 2. Because you're supposed to go and you're supposed to be putting, well, let's put in 1 point. Okay, so if we did it here, so we'll do is x approaches 2 from the left. So if you put in, well, let's start with 1.9. If you put 1.9 into that, you get the answer. I'm just going to put this as x squared minus 5x plus 6 or x minus 2. If you put 1.9 in there, you get the answer negative 1.1. If you put 1.99 in there, you get negative 1.01. If you put negative, or put 1.999, you get negative 1.001. So as we approach 2 from the left, our slope turns out to be pretty close to negative 1. Now if you do it from the right, so x approaches 2 from the right, okay, again, no, sorry. So m pq, which equals x squared minus 5x plus 6 over x minus 2. I'm going to take that out of there. Looks like too many charts. Now, if a good number to start with would be like 2.1. If you put 2.1 in there, you get negative 0.9. If you put 2.01 in there, you get negative 0.99. If you put 2.001 in there, you get negative 0.999. Okay? So this starts to approach negative 1. So the limit as x approaches 2 of x squared minus 5x plus 6 all over x minus 2 equals negative 1. Okay? Now, this is really doing limits to its basics. Now, if you wanted to, though, and we're going to work more with this tomorrow, you could factor this, and sometimes you're able to put 2 right in. So if we factored the top, let's go the limit as x approaches 2. If you put in, this would be x minus 3, x minus 2, all over x minus 2. This would cross out, and I would be doing the limit as x approaches 2 of x minus 3. Now I can substitute it in. 2 minus 3 equals negative 1. So the slope at point 2, negative 6 would be negative 1. So the slope at point 2, negative 6 would be negative 1. Okay, and then quickly the equation would be y plus 6 equals the slope times x minus 2. Y plus 6 equals negative 1x plus 2. So x plus y plus 4 equals 0 is in general form. Okay, so up to now, you've only been able to find the slope of a line. Now we could find the slope of a curve at any place using limits. Okay? So there's your assignment. You're finally going to be using that snazzy textbook.